Hey guys, welcome back to another really exciting day of pre-calc notes for you. So our last session we learned how to do some trig verifications. We're going to continue with that today. So today we are staying in section 5.2 on verify. You're going to do just a few more problems from that homework section out of the book tonight. So really nothing new in terms of what we're doing. Just I want to show you some different types of problems, maybe a little bit more challenging than what we did on the last lesson. So I want to start you with this question for question number 1. If I give you a problem and ask you to verify it that says secant theta minus tangent theta times cosecant theta plus 1 equals cotangent theta. So right away, this looks a little bit bigger than anything we did last week. And you'll also notice that the two parentheses here that I'm trying to multiply together, those aren't conjugates. So I don't want to start to FOIL this. So what we do is, don't forget this is a verify, it is a proof. So I'm going to start by recopying the side I'm working with, which would be secant theta minus tangent times cosecant plus 1. Remember, you guys should be writing these down in your notes. It's going to help you learn it and follow it much better. So what I'm going to do here, since I can't just start foiling, is maybe I change everything to sines and cosines and see if that helps me in any way. So I can change secant into 1 over the cosine minus, I can change tangent into sine over cosine times cosecant, I can change that into 1 over the sine. And my plus 1, I'm just going to write it as 1 over 1, so I see it as a fraction. Now, if you take a look at this chunk here, I've got a fraction minus a fraction, but notice that those fractions already have a common denominator, so I can go ahead and combine those to 1 minus the sine of theta over the cosine of theta. So that actually simplifies relatively nicely to there. Now, my other set of fractions does not have a common denominator, so here I'm going to go ahead and do my little cross multiplication shortcut. So I start here, that's 1 plus, and then I multiply this way, sine over the common denominator, which would have been sine. So that puts me to here. Okay, so now I have a fraction times a fraction, and we know to multiply a fraction, I multiply straight across. So let me do the denominators first. Cosine times sine just gives me cosine times sine in the denominator. Now the top, I'm going to multiply 1 minus sine times 1 plus sine. Now those are conjugates, so I am actually going to FOIL that together. And if I FOIL that together, that gives me 1 minus sine squared. So that's where I'm at right now. Now, this is where you need to look at 1 minus sine squared and remember that we have a Pythagorean identity that says sine squared plus cosine squared equals 1. Sorry, my handwriting is really bad on this thing. So therefore, if I move the sine squared over, I can see that 1 minus sine squared is equal to cosine squared. Well, then 1 minus sine squared is equal to cosine squared over cosine sine. The cosine squared over cosine, I can cancel out one of those, which will then leave me with cosine over sine, which using a quotient identity is cotangent of theta, which is what I was trying to get all along. So you can see a problem like this requires a few more steps. Now don't worry, I'm not giving you a ton of these to do. I need you to see some of this stuff. Okay, so let's try another one that may be another one that's a bit more challenging. So for this one, number 2, we're going to have 2 secant squared x minus 2 secant squared x sine squared x minus sine squared x minus cosine squared x equals 1. Well, my God, that looks terrible. Okay, so clearly this side looks, I think, a little bit more complicated than the other side, so we're going to recopy that. 2 secant squared minus 2 secant squared sine squared minus sine squared minus cosine squared. Now, what in the world do I do with that? Well, again, sometimes it's easier to go back to Algebra 1. If I go back to Algebra 1 on a problem like this, I've got 1, 2, 3, 4 terms. 4 terms, we know that we can factor by grouping. So let's try that here. So if I group these two, they have a 2 secant squared in common. And if I pull that out, that leaves me 1 minus sine squared. These two terms have a negative 1 in common. I'm going to pull that out, which leaves me sine squared plus cosine squared. Okay? Now, focus on this, like your identity bell should be ringing like crazy here. Sine squared plus cosine squared is 1, so this whole chunk just becomes minus 1 times 1. Now, on this piece here, I can see 1 minus sine squared, and hopefully you're getting better at this now. I've got 2 secant squared x times 1 minus sine squared is cosine squared. That's a Pythagorean identity. So now, if I take that and say, well, secant squared can be written as 1 over cosine squared times cosine squared over 1 minus 1, then these cancel, which just gives me 2 times 1 minus 1, which is 2 minus 1, which is 1, which is what I was trying to get. All right, let's do one more. So for number 3, if I give you cosine cubed theta plus sine cubed theta over cosine plus sine, and that's going to equal 1 minus the cosine of theta times the sine of theta. So clearly my harder side here is cosine cubed plus sine cubed over cosine plus sine. Okay, here's what makes this one interesting. This is a sum of cubes. This is like having x cubed plus y cubed. Well, you know how to factor that. You should know how to factor that. That's a SOAP question. So to factor x cubed plus y cubed, it would factor 2. An x plus y, an x squared minus xy plus y squared. That's how we factor using SOAP. So back to my problem, it's going to factor the exact same way. I'm going to have a cosine plus a sine times minus cosine times sine plus sine squared theta. And that's all still over cosine theta plus sine theta. Now the cosine plus sine thetas cancel out, leaving me cosine squared minus cosine sine plus sine squared theta. Now, focus on the first and last term. Cosine squared plus sine squared, that's a Pythagorean identity. We know that cosine squared plus sine squared is equal to 1. The minus cosine sine stays in there, and that is what I was trying to get. Okay, so do the best you can on these tonight.